Determine the left-sided limit and the right-sided limit, and the two-sided limit as x goes to 2 of h of x, and the left-sided limit and the right-sided limit and the two-sided limit as x goes to 3 of h of x, where h of x is the split expression function x squared minus 4 over x minus 2 when x is less than 2, 2x squared minus 4x over x minus 2 when x is between 2 and 3, and 3 plus 7x minus 2x squared when x is greater than 3. The first limit we want to determine here is the left side of 2, indicated by the negative superscript on the 2 of h of x. The left side of 2 on the number line is less positive than 2, or simply less than 2. And if we look down at the split expression function for less than 2, we will want to use that expression for h of x. So we can now replace h of x with x squared minus 4 over x minus 2 for this situation. The next thing to do is plug a 2 in for each of the x's. That will give us 2 squared minus 4 over 2 minus 2. 2 squared is a 4 minus 4 over 2 minus 2. 4 minus 4 is a 0. 2 minus 2 is also a 0. So we have the 0 over 0 indeterminate form. We will need to rework this. If we look back here, the numerator is a difference of squares, and it can be factored. So let's try factoring that. And it will factor into x plus 2 and x minus 2 all over the x minus 2. And we can now cancel out the x minus 2 factor in the numerator with the x minus 2 in the denominator, and that removes the 0 over 0 indeterminate form. So we have left limit as x approaches 2 from the left side of x plus 2. We can now retry plugging the 2 in for each of the x's, and that'll give us 2 plus 2. We are no longer the 0 over 0 indeterminate form. We're determinate. 2 plus 2 comes out to a 4. Now let's look at the right-sided limit indicated by the positive superscript on the 2 of h of x. The right side of 2 on the number line is more positive than 2, or simply greater than 2. But we have the limit approaching 2, so we want to stay near 2, yet greater than 2. And that means we want to use this one in the split expression function down here so that we're near 2, but greater than 2. You don't want to be greater than 3. That's not near 2. So between 2 and 3, we want to use that expression. We can replace h of x with that. We will have the limit as x approaches 2 from the right side of 2x squared minus 4x all over x minus 2. And now we can try plugging a 2 in for each of the x's. That will give us 2 times 2 squared minus 4 times 2 all over 2 minus 2. 2 squared is 4 times another 2 will be an 8 minus 4 times 2 is minus 8 over 2 minus 2. 8 minus 8 is a 0, and 2 minus 2 is also a 0. So we again have the 0 over 0 indeterminate form. We will need to rework this. And if we look back here, the numerator factors, but this time it factors with a common factor. 2x can factor out of there. And that'll leave us with an x and then minus a 2. All of this over the x minus 2. And the x minus 2 factor in the numerator can cancel with the x minus 2 in the denominator, removing the 0 over 0 indeterminate form. So we have limit as x approaches 2 from the right side of 2x. We can now try plugging a 2 in for each of the remaining x's, and that'll give us 2 times 2, which is not the 0 over 0 indeterminate form. It's determinate, and 2 times 2 is a 4. And now we can look at the two-sided limit as x approaches 2 from both sides, indicated by no superscript on the 2. Since we have a split expression function and it's changing from one expression on the left side of 2 to a different one on the right side of 2. The two-sided limit cannot be replaced with an expression for h of x. Instead, we have to rely on the results of the two one-sided limits. So now we can compare the results of the one-sided limits, the left side and the right side. Both of them came out to a 4, and therefore our two-sided limit will be that same value, 4. The next thing to determine is the left-sided limit of 3, indicated by the negative superscript on the 3 of h of x. The left side of 3 on the number line is less positive than 3, or simply less than 3. But we have a limit. We're approaching 3. We want to stay near 3 yet be less than 3. And that means we will pick this middle expression down here in the split expression function so that we stay near 3 but are less than 3. We don't want to be less than 2. That's too far away from 3. We want to stay near 3. So between 2 and 3. And therefore we can replace our h of x with that expression. 2x squared minus 4x over x minus 2. The next thing to do is try plugging a 3 in for each of the x's. That will give us 2 times 3 squared minus 4 times 3 over 3 minus 2. We will have 2 times 3 squared is a 9, minus 4 times a 3 is a minus 12. And 3 minus 2 is a 1. 2 times 9 is an 18, minus a 12 over 1. 18 minus 12 is a 6 over a 1. Anything over 1 is itself. So that one's determinate, and it comes out to a 6. Now let's look at the right-sided limit as x approaches 3, indicated by the positive superscript on the 3 of h of x. The right side of 3 means more positive than 3, or simply greater than 3. And if we look down at the split expression function for greater than 3, that will give us this expression here. So we can replace h of x with 3 plus 7x minus 2x squared for this situation. The next thing to do is try plugging a 3 in for each of the x's. That will give us 3 plus 7 times 3 minus 2 times 3 squared. So we have 3 plus 7 times 3 is a 21 minus 2 times 3 squared, which is a 9. 3 plus 21 is 24, and then a minus 2 times a 9 is a minus 18. 24 minus 18 is a 6. Now we want the two-sided limit, indicated by no superscript on the 3 of h of x. Since we have a split expression function, and the expression is changing at the 3 from one expression to the other, we cannot replace h of x with an expression for the two-sided limit. Instead, we have to rely on the two one-sided limits to get the result of the two-sided limits. So if we compare the results of the left and right side of 3, they both came out to a 6, and therefore the two-sided limit will be that same result, and it will be a 6. And there's the results of all of those separate limits.